I've always been fascinated by the mysteries of the universe, and today we're diving into one of the biggest puzzles in physics. You see, for decades, scientists have been trying to reconcile two fundamental theories that describe our universe: general relativity and quantum mechanics. But here's the thing, they just don't play nice together. That's where string theory comes in, promising to bridge this gap and potentially revolutionize our understanding of reality itself. Now you might be wondering, what's the big deal with gravity and quantum mechanics? Well, let's think about this for a second. General relativity, Einstein's masterpiece, describes gravity and how it shapes the universe on a large scale. Quantum mechanics, on the other hand, is incredibly successful at describing the behavior of particles at the smallest scales, but it struggles to incorporate gravity into its framework. It's like we have two amazing theories that work brilliantly in their own domains, but they just can't seem to get along when we try to combine them. This is where string theory steps in, offering a potential solution to this cosmic conundrum. You know, it's kind of like trying to get your cat and dog to be best friends. It's not impossible, but it's going to take some creative thinking. So what's the key idea behind string theory? Well, it turns out that instead of thinking about particles as tiny points, string theory suggests that the fundamental building blocks of the universe are actually tiny vibrating strings. These strings can vibrate in different ways, and each vibration corresponds to a different particle. It's kind of like how a guitar string can produce different notes depending on how it's played. In this view, electrons, quarks, and even gravitons, the hypothetical particles that carry the force of gravity, are all just different notes played on these fundamental strings. This unified picture is what makes string theory so appealing as a potential theory of everything. These strings are incredibly small. We're talking about 10 circumflex 33 centimeters, or about a millionth of a billionth of a billionth of a billionth of a centimeter. Yeah, that's mind-bogglingly tiny. Now you might be thinking, okay, vibrating strings sound cool, but how does this actually help with gravity? Well, it turns out that for string theory to work mathematically, it requires something pretty wild: extra dimensions. We're used to thinking about our universe in 4 dimensions, 3 of space and 1 of time. But string theory suggests that there might be 10, 11, or even 26 dimensions in total. These extra dimensions are thought to be curled up so tightly that we can't perceive them in our everyday lives. But they play a crucial role in how gravity interacts with the other fundamental forces. String theory predicts that gravity isn't actually weaker than the other forces, as it appears to be in our 4-dimensional world. Instead, it's just as strong, but most of its effects are leaking into these extra dimensions. It's like, trying to hear a whisper in a noisy room. The sound is there, but most of it gets lost in the background noise. So there you have it, string theory's ambitious attempt to unite gravity with quantum mechanics. It's a beautiful and elegant idea, but we should remember that it's still just a theory. We don't have any experimental evidence for strings or extra dimensions yet, and some critics argue that the theory is too flexible, able to accommodate almost any observation. But if string theory turns out to be correct, it could revolutionize our understanding of the universe, finally giving us a unified theory of everything. The search continues, and who knows? The answers might be vibrating right under our noses in the very fabric of reality itself.